There is a moment in every human life when time feels like it stops. A breath held too long, a memory suspended, a silence so deep that it seems to exist outside the ticking of any clock. And yet, even in those still moments, time is secretly flowing beneath us, carrying us forward whether we feel it or not. We read passengers inside a current so familiar that we rarely question its existence. Time feels automatic, obvious, natural. But what if it isn't he? What if the most fundamental thing we experience is not a background stage, but a strange cosmic invention that itself had to be created? Before we ask what happened before the universe, we must confront a stranger question. What does before even mean when time itself is missing? For as long as we've opened our eyes, our minds have been trained to imagine time as a straight line, stretching endlessly in both directions. Behind us, memories. Ahead of us, possibilities. But physics whispers a quieter truth, one that contradicts every instinct we've inherited. Time is not a river flowing through the universe. It is a feature of the universe, a function that switched on with the Big Bang, like light flooding a room the moment a lamp is flicked. And if time itself had a starting point, then asking what happened before that point may be like asking what happened before existed. It may be an attempt to walk into a room whose door has not yet been built. But the mind resists this. It pushes back. It insists there must have been something, anything before the beginning. A void, perhaps. A darkness. A silence. Because we can imagine empty space. We can imagine infinite blackness. We can even imagine nothing. But we cannot imagine the absence of time, because imagination itself requires time to function. Every thought is a moment. Every moment is a step. And without steps, how do you move at all? Yet physics stands firm. According to relativity, time and space are inseparable, braided together into a single fabric that only exists because the universe exists. Take away the universe, and the fabric disappears. Take away the fabric, and the concepts of earlier and later lose all meaning. Before the Big Bang, the universe wasn't quiet. It wasn't a dark. It wasn't still. It simply wasn't ET. But that raises its own puzzle. If nothing existed, not space, not matter, not time, then how could something erupt? How could the first moment ignite when moments themselves didn't exist? This is where language begins to fail us, and where philosophy takes its first trembling step toward the abyss. Because when we ask what came before reality, we're reusing words that rely on concepts that did not yet exist. Still, something in us refuses to accept this. Our whole lives are stories laid across a timeline. Beginnings follow causes. Causes follow previous causes. Every spark has a source. Every source has a history. And history itself is built from time. To remove time is to remove story. To remove story is to remove meaning. And so the mind rebels, reaching for any foothold in the darkness. If not time, then what? If not a sequence, then what kind of creation are we imagining? Perhaps the first step toward understanding the universe's beginning is letting go of the idea that it began in any familiar sense. Imagine standing in an absolute void, not an empty space waiting to be filled, but the absence of space altogether. Not silence waiting to be broken, but the absence of sound itself. No darkness, no light, no cold, no heat. Nothing to hold, nothing to measure, nothing to compare. A place where place is meaningless. A moment where moment has no definition. In that impossible silence, the universe did not wait. It did not anticipate. It did not prepare. Because waiting requires time, and anticipation requires sequence, and sequence requires a timeline. Instead, the universe simply erupted into being, not from a previous event, but from the absence of events. And yet, there's something unsettling about this. It feels too clean, too abrupt, too final. Our minds crave continuity, and the instant birth of the universe denies us the comfort of a backstory. It should trouble us. It should disturb us. Because if time began with the universe, then there was never a moment when the universe didn't exist. The universe doesn't emerge from empty space. It doesn't grow out of cosmic soil. It doesn't rise from ashes. It simply emerges with time as one inseparable act. No beginning, no before. Only the first flicker of existence blooming out of timelessness. But timelessness is not nothingness. And that difference matters. When we say before time, we imagine a cold void stretching endlessly backward. But an endless void is still a kind of timeline. The truth is more extreme. There was no backward, no forward, no stretch at all. Time is a dimension, not a background. Without the universe, there is no dimension to stretch across. And without dimension, even the idea of existence is undefined. Still, the human mind is stubborn. It keeps circling back to the forbidden question. If time had to begin, doesn't that imply a cause? And if causes require time, how can anything cause time itself? This is where the analogy becomes unavoidable. Asking what happened before the universe is like standing at the North Pole and asking what lies further north. The question collapses under its own definitions. The answer is embedded in the question, hidden in its structure, quietly telling us that the question cannot be answered because it cannot be asked. But even this analogy hides a deeper mystery. Because the North Pole analogy suggests a limitation of perspective, not a limitation of reality. It tells us our question is malformed. But malformed questions sometimes reveal a deeper truth. If before does not exist, then the universe may not need a cause in the traditional sense. It may exist because existence is the only way time can express itself. It may have emerged from a state not governed by time, but something more fundamental than time. Something that gave rise to time freely, without sequence. Something beyond our categories. Something outside logic as we know it. Some physicists propose that the universe could have arisen from a quantum fluctuation of a timeless field. Others imagine a deeper layer of reality where time is emergent, like heat rising from motion or music appearing from vibration. And yet others propose that the Big Bang is just a phase change in a larger timeless landscape, a transition from potential to actuality, like a spark leaping across a gap that technically did not exist. But none of these ideas fully satisfy, because we still carry the burden of the same ancient thought. Something cannot come from nothing. Something cannot ignite without a trigger. Something cannot begin without an earlier state that prepared it. And so we fall into a strange paradox. The universe may have no before, yet something must have set the first moment into motion. We feel the contradiction rising like a tide. Everything we know demands cause. Everything physics shows us denies it. We are trapped between intuition and reality, between the comfort of narrative and the cold truth of the cosmos. But maybe this tension is the point. Maybe reality is not built to fit the shapes our minds evolved to understand. Maybe our language breaks because the universe speaks in a dialect older and more alien than thought itself. And so we return to the darkness before the first second, not a darkness that exists, but a darkness defined by absence, a darkness without duration, a darkness without boundary, a darkness that isn't a dark, a realm where there is no realm, a silence that doesn't wait for sound, a condition that defies the word condition. From this, the universe erupts, carrying time on its back like a newborn carried by its mother. And from that first instant, every moment that has ever existed begins its long, unfolding story. Yet the deepest question remains, suspended like a fragile ember glowing in the void. If time began, something must have caused it to begin. We often imagine nothingness as a quiet, empty room, a place without disturbance, without motion, without anything at all. But the universe has never been so simple. When we peel back the layers of existence and descend into the smallest scales nature allows, we find a truth far stranger than silence. The void is neither calm nor hollow. It is restless, vibrating with invisible tension, whispering with the energy of fields that never sleep. What we call nothing in physics is not an absence, but a stage brimming with hidden players, each flickering in and out of being as if reality itself cannot resist the urge to create. And so, after standing in the philosophical darkness of the previous act, the realm without time, we take a single step forward into a different kind of darkness. Not the darkness of absence, but the darkness of complexity. A place where emptiness is alive. A place where the vacuum is a seething ocean of possibilities. This is the quantum empty, a nothingness that isn't empty at all. To understand this strange landscape, we must let go of common sense once again. On the surface, a vacuum seems like the simplest thing imaginable. Remove matter, remove light, remove air, and what remains is nothing. But physics disagrees. When we strip the universe down to its barest form, removing every atom, every photon, every grain of dust, we find that something lingers beneath the simplicity, something deep, something fundamental. Beneath space lies a web of quantum fields invisible, omnipresent, and unavoidable. These fields are not the result of particles. They are the source of particles, and they never turn off. Imagine a stage before the actors arrive. The lights dim, the curtains closed. To the audience, it looks empty. But behind the curtain, the set is already built, the machinery humming quietly, the wires tense with potential. At any moment, something might move, something might shift. A new act might begin. This is the quantum vacuum, a theater of constant preparation. Even in its lowest energy state, the vacuum boils with activity. Virtual particles appear, vanish, appear again, flickering so quickly that no eye could ever catch them, yet their effects shape everything we see. This chaotic dance is not optional. It is mandatory. It is the grammar of reality. Every particle you've ever touched, every atom that has ever existed, every moment you've ever lived, emerges from the restless undercurrent of these fields. And here the paradox deepens, because if the universe arose from something, but not from time and not from matter, then perhaps this quantum fabric, this endless trembling sea, is the closest thing the universe had to a before. The vacuum is not a prelude, it is a foundation, not a void, but a womb. Yet this truth is difficult to digest. We've spent our entire lives believing that emptiness means nothing. A blank page, a silent room, a dead background. But the quantum empty refuses that definition. It is charged, active, volatile. Even when perfectly empty, it is never still. The vacuum is the most misunderstood character in the story of reality. It is not a backdrop, it is a co-author. But why does the vacuum tremble? Why does nothingness behave like a nervous heart, beating with invisible motion? The answer lies in the uncertainty woven into the fabric of quantum mechanics. On the smallest scales, nature refuses absolute stillness. A field cannot freeze perfectly, just as a flame cannot hold itself motionless. Motion is not an event in the quantum realm. It is a requirement. The vacuum fluctuates because it must. To stop would violate the very laws that make existence possible. So when we speak of nothingness, we are speaking of this trembling, shivering ocean of fields. We are speaking of a ground state that hums with latent energy. We are speaking of a stage where the actors are shadows, appearing and disappearing in flashes too brief to count. This, then, is our new paradox. The vacuum is full of potential, full of fluctuations, full of the seeds from which matter and energy may bloom, full of the instability that makes creation possible, and full of the same strange mathematical heartbeat that likely shaped the birth of the universe itself. The deeper we dive, the stranger it becomes. Quantum fields are everywhere, stretching across the entire cosmos, intertwined in ways we barely understand. They are the threads from which reality is woven. They define what particles can exist, how those particles behave, how forces push and pull, how space expands, how light bends, how galaxies form. Everything exists because these fields exist, and every field exists even when it appears that nothing is happening. But is this vacuum eternal? Has it always existed? Or is it merely a property of this universe, a temporary scaffold that appeared when the cosmos blinked into being? The question burns like a spark in the dark. Some physicists believe the quantum vacuum predates the universe. Others argue it emerged with space-time itself. But all agree on one haunting truth. If anything existed before existence, it would look nothing like our human intuitions. It would look far more like this restless quantum fabric than any familiar form of emptiness. Perhaps the most astonishing idea is that the vacuum can generate universes, that the wild fluctuations inside it are not merely random noise, but creative engines, that under the right conditions, a small pocket of vacuum could inflate, stretch, and blossom into a full-fledged space-time, a universe like ours. Maybe it has happened countless times. Maybe every fluctuation is a tiny attempt at creation, and only a select few achieve the expansion needed to become entire realities. This thought is dizzying. It tears apart our sense of uniqueness. If the vacuum can generate universes, then reality might be a forest, and our universe is only one tree. Or perhaps it is an ocean of bubbles, each universe a shimmering sphere rising and bursting, endlessly. And beneath them all, sustaining them all, lies the quantum fabric, the trembling nothingness that births everything. And yet, this kind of nothingness does not feel like nothing at all. It feels like the opposite, a fullness, a churning, vibrating, invisible storm. A mother field that holds possibility the way a seed holds the shape of a future tree. The quantum vacuum is potential carved into the structure of reality. It is not the absence of being, it is the possibility of being. Still, this idea can be unsettling, because if the vacuum is the source of particles, and particles form atoms, and atoms form stars, and stars form us, then everything we know, everything we love, everything we fear, is built on top of a foundation that looks chaotic and unstable. The bedrock of the universe is not solid. It is a perpetual flicker, a blur of creation and annihilation, a field of infinite possibility vibrating beneath our feet. But maybe that is why the universe is so rich, so alive, so endlessly creative. If the vacuum were truly still, perhaps nothing would happen at all. No stars, no galaxies, no time, no complexity. A perfect stillness may be the true emptiness, and a trembling vacuum may be the only path to a universe. The thought brings a strange comfort. It suggests that existence is not an accident, that the universe was born not from silence, but from a natural consequence of the quantum fabric. Not a miracle, but a pattern. Not a mistake, but an unfolding. And in this pattern, the vacuum is both creator and creation. It is the place where virtual particles borrow energy and vanish before the universe notices. It is the background hum that gives birth to the Casimir effect, where two metal plates in a vacuum feel a mysterious force pushing them together, a force coming not from outside, but from the vacuum itself. It is the foundation behind the slow expansion of space, fueled by dark energy that seems to emerge from the vacuum's own pressure. All of these clues point to the same truth. The vacuum is not empty. It is full of something deeper than matter, deeper than energy, deeper than time. It is the quiet machinery beneath the stage of reality, humming with an energy that refuses to sleep. And so, as we stand here on the edge of the smallest scales, staring into a darkness that isn't dark, a new question rises from the depths, like a luminous spark. Could this vibrating nothingness be the seed of everything? There is a moment in the birth of the universe so small, so fleeting, so violently compressed, that even our bravest equations shatter when they approach it. A moment so early that time itself had barely taken its first breath. If the universe were a book, this moment would be the torn page at the very start, the place where the first words should have been. But R&T physicists call it Planck time, a name that tries to describe the indescribable. 10 to the minus 43 seconds after the universe began. A span so brief that calling it brief is like calling a supernova warm. It is the smallest unit of time our physical laws allow. And beyond it, we encounter something stranger than darkness. We encounter the Planck wall, the boundary where knowledge dissolves. To reach it, we must move through a universe that is still raw with heat, still bright with incomprehensible energy. The cosmos, in these earliest instants, is not the delicate tapestry of stars and galaxies we know today. It is a boiling storm of space itself, too dense for light to travel, too chaotic for shapes to form. Time is young. Space is young. Everything is young. And yet, even in this violent infancy, there is a frontier we cannot cross. As we dive backward into the first fractions of a second, our physics works, beautifully at first. General relativity describes the shape of space. Quantum mechanics describes the jitter of particles. For a while, they coexist like two musicians playing different melodies that somehow harmonize. But as we approach the beginning, the notes grow louder, sharper, more discordant. Gravity becomes intense enough to warp reality on a quantum scale. Quantum fluctuations swell large enough to twist gravity in return. The two great theories of physics begin to argue, each insisting it alone knows the truth. And as their disagreement intensifies, our equations begin to spin out of control. When we reach Planck time, they simply break. It is not nature that fails here. It is us. Our models cannot survive the pressure. This is why physicists describe the boundary as a wall. Not a wall of stone, not a wall of fire, but a wall of ignorance, the limit beyond which our understanding cannot pass. Planck time is the earliest moment we can speak about with confidence. Before this, even saying before becomes slippery, dangerous, almost meaningless. Yet the urge to look beyond it is irresistible. We want to know what happened in that forbidden region, in that primordial landscape where gravity and quantum mechanics fuse into something utterly alien to our intuition. We want to know what existed before the first measurable moment. But the Planck wall stands in our way, shimmering like a cosmic mirage. Cross it, and everything we know vanishes. Stay on this side, and we remain trapped in questions with no answers. Still, the human mind has always been drawn to forbidden edges. We lean toward them instinctively, as if the unknown carries its own kind of gravity. And so we approach the Planck wall slowly, with caution, knowing it is the closest thing to a cosmic horizon that the early universe will ever allow. Imagine shrinking yourself smaller than any atom, smaller than any particle, and then smaller again by a factor so vast that the numbers lose meaning. Imagine compressing your perspective until the universe itself seems infinite and empty, except for a single violent flash of creation burning at the center. Each step backward in time doubles the tension. Each fraction of a second brings you closer to the impossible. But when you reach Planck time, when you finally stand before that hidden curtain, something extraordinary happens. The world stops making sense. Space loses its smoothness. Time loses its direction. Energy loses its shape. The very ideas that form the backbone of physics dissolve into unpredictable foam, quantum foam, a chaotic sea of fluctuations so extreme that space itself is shredded into bubbles of possibility, each one a brief experiment in geometry. Some expand, some collapse, some twist into shapes no equation can capture. Gravity is no longer gentle curvature. It is a violent, jittering force competing with quantum uncertainty itself. At this scale, the universe is not a place. It is an edictoidhood argument, a chaotic debate between laws that cannot compromise, and in the aftermath of their disagreement, the universe remains silent, refusing to reveal which law truly governs these conditions. This is why physicists dream of a theory of quantum gravity, a single elegant framework where the language of the very small and the language of the very large become one. Strings, loops, extra dimensions, hidden symmetries. Each of these theories represents humanity as attempt to peer through the Planck wall. But none of them have yet pierced the veil. And so the wall remains, unwavering, a curtain drawn across the first instant of creation. Yet the most haunting part is this. The Planck wall is not just about limits. It is about possibilities. Because beyond it may lie the true origin of everything. Beyond it may lie a realm where time is not linear, where space is not dimensional, where energy is not stable. A realm where the universe could have emerged not from a point, but from a transformation. Not from a seed, but from a shift. Not from nothing, but from something so alien we do not yet possess the tools to describe it. And so we find ourselves staring at a cosmic border that feels almost mythical, the closest thing science has to an edge of creation. The known dissolving into the unknown. The familiar giving way to mystery. Every step we take toward understanding reality brings us back to this same boundary, this same unreachable moment. this same silent curtain that refuses to lift. But mystery has its own kind of magnetism. The Planck wall is not just an obstacle. It is an invitation. It beckons us to imagine, to theorize, to question the foundations of existence. And in doing so, it becomes the emotional peak of our journey. The place where the viewer feels the tightening of impossibility, the sense that we are standing at the threshold of something immense, something just out of reach. The closer we approach, the more the desire for answers grows, the more the mind strains to pierce the veil. What lies beyond? A collapsing universe from a previous cycle? A quantum fluctuation erupting from timelessness? A landscape of higher dimensions curled so tightly they explode into expansion? A state of pure mathematics waiting to crystallize into physical law? Or perhaps something stranger, still something that does not fit within the categories of thought or the boundaries of intuition. Whatever lies beyond the Planck wall, it cannot be described by classical physics. It cannot be mapped by equations designed for smooth space or calm energy. We are dealing with a moment when the universe was too small for certainty, too dense for smoothness, too wild for logic. A moment when existence and non-existence may have been indistinguishable. A moment when the rules that govern atoms and galaxies had not yet emerged. This realization forces us into a different kind of awe, not the awe of size or scale, but the awe of ignorance, the awe of facing something so far beyond our understanding that we cannot even be sure our questions are valid. And yet, the tension draws us closer. The desire to know burns brighter, because behind that wall may lie the engine that created reality. And so we stand in front of the Planck curtain, feeling the pressure of the unknown pressing against us. The universe on this side is young, incandescent, exploding with heat. But on the other side, if side even has meaning, lies a realm untouched by measurement, untouched by light, untouched by certainty. A realm where our physics collapses, leaving only possibility behind. The Planck wall does not protect a secret. It embodies one. And beneath its mystery lies the question that now pulses through the entire documentary. What existed before the first measurable moment? The universe will not answer easily. The curtain will not lift without a fight. But we have reached the boundary, and beyond it lies the forbidden landscape we seek to explore. So what could exist beyond the Planck wall before the first measurable moment? There is a point in every journey where the horizon suddenly expands, where the world we thought we understood reveals itself as only one room in a mansion of impossible size. Until now, we have peeled back layers of reality like a cosmic archaeologist, the timeless void, the trembling quantum vacuum, the impenetrable Planck curtain. Each act drew us closer to the origin. Each step narrowed the field of vision. But now, in an instant, the narrowing stops. Our perspective flips. The frame widens, and what appears is a landscape so vast, so chaotic, so overflowing with universes that our own begins to feel like a grain of dust drifting in a limitless storm. We have arrived at the realm of eternal inflation, the idea that the Big Bang was not a singular event, but one spark in a cosmic blaze that never truly ends. To understand this unsettling idea, we must revisit a moment when the young universe was still unimaginably dense, a moment when inflation, a rapid, accelerated expansion, tore space apart at speeds far faster than light. In less than a heartbeat, the universe ballooned from subatomic size to nearly macroscopic scale. Inflation was not gentle growth. It was an explosion of space itself, driven by an energy locked into the vacuum. But here is the part that turns everything inside out. Inflation might not stop everywhere at once. In fact, according to the mathematics, inflation should continue forever in most places, even as it ends in pockets. And each time it stops, a universe is born. Our universe, with its galaxies, stars, planets, and people, could be one such pocket. A bubble in an ocean, a flare in a storm, a local calm in an infinite tempest of expansion. This is not metaphor. It is one of the most serious scientific ideas ever proposed. A picture of reality where the Big Bang was simply our beginning, not the beginning. A picture where countless other beginnings unfold, endlessly, scattered across an inflating background that stretches on without end or boundary. The implications are staggering. What we call the universe may be nothing more than a leaf floating in a boundless cosmic forest. And the forest does not stop growing. It blooms forever, spawning pocket after pocket, bubble after bubble, reality after reality. Imagine an infinite ocean bubbling with foam. Each bubble expands into a universe with its own stars, its own physics, its own unfolding of time. Some bubbles grow large, some burst early, some freeze in stillness, some burn hot with violent beginnings. Each bubble is isolated, forever separated from the others by regions of rapidly expanding space. No traveler could ever cross from one to the next. No message could ever bridge the gap. They share an origin in inflation, but never a future. And yet, the ocean that surrounds them never rests. It continues to inflate, generating new bubbles without pause. This is eternal inflation, a universe not of one beginning, but of countless beginnings, each igniting like sparks struck from the same cosmic stone. At first, the idea feels exhilarating. Then it becomes terrifying. Because in this picture our universe is not only small, it is not special. It is not unique. It is simply one realization among infinite possibilities. The constants we consider sacred, the speed of light, the structure of atoms, the balance that allows stars to burn, may be entirely different in other bubbles. Not because they chose to be, but because the laws of physics themselves fluctuate across the multiverse. And this realization triggers a strange emotional shift. First awe, then smallness, then a quiet fear. The fear that everything we are, everything we know, is just one local arrangement in a sea so large it defies imagination. The fear that countless versions of reality lie beyond our reach, some dead, some vibrant, some alien beyond recognition. And the fear that we will never see them, never touch them, never confirm their existence except through mathematical shadows. But fear is only part of the story. Because once that fear settles, something else rises behind it. Wonder. Pure, unfiltered wonder at a universe, or rather, a multiverse, that refuses to be confined to a single storyline. Consider this. If inflation is eternal, then the multiverse has no center, no edge, no preferred universe. It is a quilt stitched together not by design, but by an endless unfolding of chance. Each pocket universe is like a cosmic lottery ticket. Some produce structure, some collapse into nothingness, some expand into beautiful complexity. And ours, for reasons we still struggle to understand, landed in the narrow range where life is possible. This raises uncomfortable questions. Why are the physical constants in our universe so perfectly tuned for stars to form? Why can atoms bind? Why does gravity have just the right strength? Why does the vacuum energy allow galaxies to grow instead of tearing them apart? In a single universe model, these coincidences seem impossible, but in a multiverse, they become inevitable. If countless universes exist, each with different properties, then by pure probability, some must evolve the right conditions for life. And we happen to live in one of them because we would not exist in the others. This explanation does not diminish our universe. It contextualizes it. We are a rare flower blooming in an infinite field, a possibility realized in a landscape of possibilities. Yet this cosmic perspective comes with another paradox. If universes are constantly forming and inflation never ends, then time itself might not apply to the inflating background. The sea that gives birth to universes may be timeless, not because it lacks sequence, but because sequence loses meaning when expansion becomes continuous and unbounded. In such a landscape, before and after dissolve, there is only eternal generation, eternal growth, eternal possibility. Picture it, an infinite expanding space where pockets of calm emerge, cool, and blossom into universes. Behind each bubble lies a region of space that continues to inflate so rapidly that no newborn universe can reach its siblings. The inflating sea itself grows faster than any universe inside it. The background roars forward. The bubbles drift apart, isolated forever. And in this roaring sea, new universes ignite like sparks leaping off a grinding wheel. Some might be similar to ours. Others might be impossibly strange dimensions curled in knots, forces so strong that atoms cannot form, or spaces so fractured that time branches like lightning instead of flowing like a river. We will never see them. But the mathematics suggests they exist, and not just a few, but possibly an infinity. This idea marks the documentary Cosmic Zoom Out, the moment the viewer feels the floor drop out from under their sense of scale. For centuries, humans believed the Earth was the center, then the sun, then the galaxy, then the universe. But eternal inflation suggests even the universe is not the center, because there may be no center at all. And if this inflating sea has existed forever, if it needs no beginning, then our own Big Bang was not a creation moment. It was a local event, a moment when one pocket of the inflating background dropped in energy, stopped inflating, and expanded into the universe we inhabit. Suddenly, before the Big Bang becomes a doorway, not a wall. If the background is eternal, then the Big Bang becomes the start of our universe, but not of everything. It becomes a transition, not an origin, a local spark in a timeless fire. This brings us to a profound emotional crossroads, the realization of our smallness. We are not cosmic royalty living in a singular universe. We are wanderers in a single bubble drifting through a vast multiverse ocean. Our universe might be 13.8 billion years old, but the inflating sea might be ageless, a realm without beginning or end, always expanding, always generating, always becoming. It is easy to feel insignificant in such a picture, but insignificance is not the message. The message is possibility. The message is that creation may not be a one-time miracle. The message is that existence might be richer than any story we have ever imagined. A cosmic ecosystem where universes bloom in abundance. And yet, as awe swells, a deeper mystery surfaces, the mystery we cannot escape. If universes arise from bubbles in an inflating background, and the background itself stretches endlessly, then what fuels the inflation? What drives this continuous expansion? What keeps the sea from freezing into stillness? The question becomes even sharper when we consider the energy powering inflation. It is not ordinary matter. It is not radiation. It is a strange form of vacuum energy, one that repels instead of attracts, causing expansion to accelerate. If this energy has always existed, then the inflating sea may be eternal. But if it had to be generated, then we are forced to ask what generated it. We find ourselves standing on another cosmic threshold, looking not only at infinite universes, but at the mechanism that births them. Eternal inflation offers an answer, but it also opens a new door, a darker door, a larger door. And when we peer through it, we find a question more ancient and more profound than the multiverse itself. Because even if universes are born endlessly, what births the inflating sea itself? There are places in the universe we cannot reach with rockets, telescopes, or instruments. But there are also places we cannot reach with language, logic, or intuition. The deeper we go into the birth of reality, the more these two forms of distance intertwine. Behind the Planck wall, past the roaring sea of eternal inflation, beyond even the flicker of quantum vacuum energy, lies a realm where the universe has not yet become a universe. A realm without coordinates, without clocks, without the gentle scaffolding of space and time. It is not emptiness. Emptiness requires a place to be empty. It is not darkness. Darkness requires light to be absent. It is something more primitive, more abstract, more foundational. A condition of possibility, not a place. A quiet, trembling blueprint from which existence might crystallize. Physicists call this the pre-geometric state, a domain where gravity is quantum, where geometry is not smooth, where time is not flowing because there is nothing yet for it to flow through. If all previous acts in this story peeled away the layers of the cosmos, this one strips away the concept of layers itself. Imagine waking from a dream, where the world has no up or down, no left or right, only shifting patterns, relationships, and transformations. The dream is not a world, but a dance of meaning, a dance that hints at shape without committing to structure. This is the timeless realm envisioned by theories like string theory, loop quantum gravity, and causal sets. Not competing pictures, but different attempts to describe the same impossible frontier. A reality where reality is not yet real. It feels disorienting at first because everything we've ever known requires space to move in and time to move through. But the equations whisper a different truth. Space may not be fundamental. Time may not be fundamental. They may be emergent conveniences of scale, blooming out of deeper hidden rules, like temperature emerging from molecules or color emerging from vibrations of light. To accept this, we must let go of the idea that the universe began as a tiny dot. The timeless realm is not a dot. It is not a point. It is not an object sitting in a void. It is more like a network of potential events, connected not by spatial distance, but by mathematical possibility. Events that are not yet ordered, not yet sequenced, not yet bound by geometry. In loop quantum gravity, for instance, space dissolves into discrete units, tiny atoms of volume woven together by probability. Not cubes, not particles, but loops of information that link and unlink, creating a spiderweb of existence so small that geometry disappears. Distances are not distance. Positions are not position. A point can be everywhere at once, or nowhere at all. In string theory, reality emerges from vibrating strings far smaller than the smallest particle. These strings do not live in space. They generate space. Their frequencies write the laws of physics like notes, composing a cosmic symphony. The harmonies of these strings determine particles, forces, and eventually, the fabric of spacetime. Below the strings, nothing familiar exists, only the raw mathematics of vibration. And in causal set theory, the universe is a growing chain of events, not spread through space, but connected by cause and effect. Space is an illusion formed by patterns in this chain. Time is the order in which events build on one another. Geometry emerges only when enough events accumulate to give shape to something that resembles distance. All three frameworks point to the same idea. Before the universe existed, something existed, but it was not spatial or temporal. It was relational, structural, mathematical, a network of pure possibility waiting for a rule to animate it. This picture can feel unsettling. It removes the comfort of physicality. It replaces the tangible with the conceptual. But there is an elegance to it, a quiet serenity. If the universe is not a place, but a process, then the story of existence becomes the story of emergence, a story where nothing becomes something not by explosion, but by transition, not by a spark, but by a shift from one kind of being to another. Imagine the timeless realm as a silent ocean of possibilities. No waves, no current, just depth. And from this depth, patterns begin to form. Subtle relationships strengthen. Loops knot into shapes. Vibrations align. Events link into chains. Slowly, structure emerges. Slowly, the raw potential condenses into something recognizable. It is not space yet, not time yet, but it is the precondition for both. Then, at some unimaginable threshold, a phase transition occurs. Like water freezing or vapor condensing, the pre-geometric realm undergoes a transformation. Its patterns crystallize into spacetime. Its loops form volume. Its strings define forces. Its causal network develops direction. Time appears not as a law, but as a consequence, the alignment of cause and effect into a single unfolding. The birth of the universe, in this view, is not the ignition of a fire. It is the emergence of structure from chaos, order from abstraction, geometry from relation, time from timelessness. It is a creation story without a creator and without a stage. The stage builds itself. If this sounds metaphysical, it is because it sits at the boundary where physics meets philosophy. When we talk about the pre-universe state, we are not describing a physical place. We are describing the conditions under which physicality itself becomes possible. The rules that make rules. The laws that generate laws. This is where the documentary shifts from cosmic spectacle to intellectual revelation. The viewer feels suspended, as if the ground beneath reality is no longer solid, but fluid. Time loses its authority. Space loses its meaning. Reality becomes something dreamlike, something that hovers between form and formlessness. And in that dreamlike suspension, a new understanding dawns. The universe may not have emerged from nothing. It may have emerged from a deeper kind of something, a something that does not resemble matter or energy or space or even time. An informational substrate, a mathematical lattice, a pre-geometric web. The deeper we explore, the more ordinary language betrays us. We say before, but there was no before. We say realm, but there was no space. We say state, but nothing was stable. Still, the mind reaches, stretches, aches for comprehension. Picture a tapestry so tightly woven that from afar it appears as one smooth surface. But zoom in far enough, and you see individual threads, each crossing another, each contributing to the pattern. Now imagine zooming even deeper, down to where even threads dissolve into raw potential, the idea of weaving before any fabric exists. This is the pre-universe state, the loom itself, not the cloth. And once the loom arranges its first pattern, space-time emerges like fabric rolling outward. The universe flows into being, each moment stitched to the next, by the rules carved into that pre-geometric design. But the great question remains: why did the loom activate? Why did the pattern crystallize? What mechanism allowed time to emerge from a timeless realm? Scientists propose possibilities: vibrational instabilities, quantum tunneling, symmetry breaking, phase transitions. But these are metaphors as much as explanations. Because to speak of mechanisms before time exists is to speak in a language that does not yet apply. So we are left with a paradox, a tension that vibrates through this entire act. The universe emerges from a realm that cannot be described using the universe's own laws. This tension does not frighten us. It expands us. It forces us to loosen our grip on certainty. It invites us to consider that reality might be a story told in layers, first mathematical, then geometric, then physical, then experiential. By now, the viewer feels the shift. Confusion melts into clarity. Clarity settles into wonder. Wonder stretches into a soft serenity. Because the more we understand that time may not be fundamental, the more we are freed from the burden of imagining beginnings in a linear way. If time emerges from something deeper, then the birth of the universe is not a moment in time. It is the moment when time acquires meaning. And when time acquires meaning, history begins. Physics begins. The universe begins. But the process that allowed time to emerge, that strange, silent mechanism, rests in the shadows of the pre-geometric realm, still beyond our reach. So we end this act standing at another conceptual horizon, gazing into the structure beneath structure, listening for an answer that has not yet taken shape. If time emerges, what mechanism allows emergence itself? There is a moment in every great mystery when the gaze of the seeker turns inward. When the question being asked is no longer about the universe, but about the mind trying to understand it. We have chased the earliest moments of existence across physics, mathematics, and cosmology. We have passed through timeless realms, quantum seas, and inflating infinities. But now we arrive at a different frontier, not a boundary in nature, but a boundary in ourselves. The question, what came before the universe, now reveals its deeper shadow. Does the word before even make sense without time? For thousands of years, philosophers wrestled with this. Aristotle insisted that time was the measure of change, and without change, time could not exist. Kant argued that time was not out there in the universe, but a built-in structure of the human mind, a necessary lens through which we perceive reality. Modern cosmology adds another twist. If time begins with the universe, then asking what happened before it is like asking what lies north of the North Pole. The question collapses under its own weight. Yet the mind cannot help but ask it. Something in us refuses to accept the idea of a beginning without a cause, a creation without a sequence, an origin without a prior moment. Causality is our deepest instinct. Everything we know unfolds in chains. A mother before a child, a seed before a tree, a spark before a flame. So when we reach the ultimate boundary, the emergence of the universe, we instinctively reach backward along that imagined chain, searching for the link that must precede the first. But every instinct we carry may be misleading us. We are creatures conditioned by time. Our bodies age, our memories form in sequence, our emotions unfold in rhythms we cannot break. The idea of before is etched into our biology. To abandon it feels like abandoning ourselves. And yet, perhaps that is what this question demands, not better physics, but a quieter ego. A willingness to admit that our minds may not be wired to grasp the conditions preceding time, just as a fish cannot imagine dryness, or a shadow cannot understand the source of light. When we say before, we assume a temporal framework that may not have existed. When we imagine a sequence, we are projecting a mental habit onto something that might not obey it. It is tempting to think that with better equations, we could simply calculate our way past this barrier. But the barrier may not be mathematical. It may be cognitive, a boundary drawn not by nature, but by the limits of our own perception. Consider this. Every myth humanity has ever created, from creation stories to cosmic eggs to divine authors, emerges from the need to place events in an order. Something must come first. Something must precede. Something must ignite the story. Our cosmologies aren't just attempts to explain the universe. They are reflections of our own psychology. We build timelines because we experience life as a timeline. We build narratives because we think in narratives. Even in physics, the same bias appears. Causality is assumed because it works at large scales. But when we dive into quantum mechanics, causality becomes slippery. Events can be unordered. Particles can exist in states that do not respect sequence. Some interpretations suggest that cause and effect might be emergent phenomena, not fundamental ones. And if causality is emergent, then before and after are not fundamental either. The human brain evolved to navigate danger, not to contemplate timeless realms. Our ancestors survived by predicting the next moment, not by questioning the existence of moments themselves. This evolutionary lens shapes our every thought. It makes linear time feel natural, even inevitable. But nature has no obligation to obey our intuition. When scientists say time may have emerged from a deeper reality, we imagine a prior state because our language forces us to. But prior is another word sabotaged by time. How can something happen before time if time does not yet exist to carry such a happening? Quantum philosophers push this further, arguing that the universe may not have come from anything. It may have transitioned, or manifested, or crystallized. Words stretch. Meanings blur. Every verb we use smuggles time into the picture. Even the phrase time emerged implies a sequence. The mind cannot express timelessness without betraying itself. This is the heart of the paradox. The universe might not have a before, but the human brain cannot imagine a world without one. So perhaps the great boundary we face is not cosmic, it is psychological. When the cosmos asks us to let go of before, it is asking us to let go of the mental scaffolding that makes meaning possible. And this is where introspection becomes unavoidable. We realize we may be staring at a truth our minds did not evolve to perceive. Even Kant warned us, the deepest structures of reality might exist beyond the forms of intuition we are capable of experiencing. Time and space might be conveniences, not constants. Categories of thought, not categories of existence. This realization humbles us. It presses gently against our sense of self. It reminds us that intelligence does not guarantee comprehension, and curiosity does not guarantee access. We are instruments tuned to the middle scale of the universe. Not too small, not too large, perfect for survival, imperfect for metaphysics. And in this gentle humility, a quiet acceptance begins to form. Perhaps the universe does not owe us an answer in the format we expect. Perhaps the ultimate question cannot be, what came before? Perhaps the ultimate question cannot even be a question in the language we use. If time is emergent, then sequence is emergent. If sequence is emergent, then causality is emergent. And if causality is emergent, then the question of before dissolves like breath on a mirror. We stand, then, at the edge of the most profound horizon of all, not a physical boundary, not a mathematical singularity, but a cognitive limit. The limit of creatures who evolved within time, trying to understand a realm where time does not apply. The camera of the documentary turns inward now, resting not on galaxies or equations, but on the face of the viewer. Because this act has always been about the mind, its strengths, its limits, its stubborn insistence on shaping reality into familiar forms. In this introspective light, the answer begins to shift. Not because reality has changed, but because we recognize the shape of our own questions. We begin to sense that the puzzle may not be solvable in the way we hoped not, because the truth is hidden, but because we lack the lens required to see it. And so this act closes not with frustration, but with a quiet, philosophical sigh, a recognition that sometimes the deepest truths are not beyond us. They are beyond the questions we know how to ask. The universe may not be refusing to answer. We may simply be speaking the wrong language. Perhaps the answer is not beyond us, but beyond our ability to ask the question correctly. There is a moment in the birth of every universe that is neither an explosion nor a spark, neither a decision nor a command, but something quieter, stranger, and far more delicate. A moment when potential begins to lean toward actuality, when the probability waves of countless futures tilt ever so slightly toward one unfolding path, when the cosmic dice, jittering in a timeless hand, finally settle into a configuration that allows a universe to begin. This is the moment creation chooses to happen, not in the human sense of intention or will, but in the mathematical sense of emergence. A moment defined by transitions, by symmetry breaking, by the delicate choreography of laws that did not yet fully exist. We often imagine creation as a singular event, a bang, a flash, a dramatic beginning. But the deeper we explore the frontier of physics, the more creation resembles a process, a gradual crystallizing from the haze of possibility into the clarity of structure. Before the universe became hot, dense, and expanding, it existed as something more ghost-like, a wave function of primordial potential, a state where all possible configurations of geometry and energy shimmered in superposition. Nothing was fixed. Nothing was chosen. Everything was waiting. Then something shifted. Perhaps it was quantum tunneling, the sudden transition of the pre-universe state from one energy configuration to another. Just as a particle can leap across a barrier it has no classical right to cross. Perhaps the timeless realm teetered on the edge of instability and then slipped into a lower energy state, unleashing the inflationary cascade that would become the Big Bang. Or perhaps a symmetry broke, a perfect balance fractured into uneven parts, separating forces that were once unified, allowing structure to form. Symmetry breaking is always at the heart of creation. Perfect symmetry is sterile, frozen, incapable of complexity. But break it just slightly, and suddenly the universe gains the potential for form. A field that once stretched uniformly becomes lumpy. A balance that once held everything in equilibrium now tilts, forming gradients. Forces differentiate. Particles condense. The uniform sea of possibilities fragments into an evolving landscape of actualities. In that sense, creation is not the beginning of something. It is the end of perfect symmetry. It is the moment when the universe chooses imperfection so that it can become dynamic, structured, alive. But this choice is not conscious. It is statistical. The quantum fabric of the pre-universe was a sea of probabilities. And like all quantum systems, eventually the probabilities collapse into an outcome. Not because someone observes them, but because existence itself demands stability. A universe cannot remain forever in pure potential. Eventually, a transition must occur. Eventually, a single branch becomes reality. Quantum cosmology suggests that the wave function of the universe collapsed into a definite state, one that permitted inflation, expansion, and the birth of space-time. Out of all the possible universes encoded in that wave function, ours became the path of least resistance. The universe did not choose consciously, but it selected statistically. The transition that allowed structure to unfold was the one that succeeded. And once the transition occurred, everything that followed was locked into motion. Energy condensed into particles through processes we still strive to fully understand. Vacuum energy morphed into fields. Fields gave rise to forces. Forces sculpted matter. Matter coalesced into stars. Stars forged elements. Elements built planets. From planets came oceans. From oceans came life. From life came observers capable of asking what triggered the very first moment. Vacuum instability may have played the starring role. When the vacuum sits in a metastable state, high energy, but not highest, it can suddenly decay into a lower energy configuration. Such a decay would release a colossal burst of energy. A universe could form from that transition, swell outward, cool, and eventually settle into the rich complexity we see today. In this view, creation is not intentional at all. It is a natural consequence of vacuum energy searching for stability. Or perhaps the universe emerged through quantum tunneling across the Planck barrier, a spontaneous materialization out of a timeless pre-space, in the same way particles can appear temporarily from the vacuum. According to some models, universes tunnel into existence the way raindrops condense from invisible vapor. Not miraculous, not impossible, just rare. Each explanation offers a piece of the story, but none captures the full picture. Creation is too subtle, too layered, too interwoven with physics that has not yet been fully written. But what unites all these ideas is the recognition that creation is not simply a starting point, it is a transformation, a shift from potential into actual, a choice made not by a hand, but by the mathematics of existence itself. And in this moment of transition, this collapsing wave function, this breaking symmetry, this tunneling shift, the entire history of the universe is encoded. Every star that will ever form, every atom that will ever bind, every consciousness that will ever ask why the universe exists. All of it emerges as consequences of that first transition. Like dominoes falling through time, triggered by a single act of emergence, creation becomes not a bang, but a story. A story written in fields and forces, shaped by probability, guided by the natural laws that crystallized in the very act of becoming. The Big Bang is simply the first visible word of that story, not its cause, not its essence, not its origin, but its first expression. And so, after our long journey through physics, philosophy, inflation, quantum foam, and timeless states, we arrive at the quiet revelation that creation is not something the universe experienced once. It is something the universe experiences continuously. Every moment of structure, every emergence of order, every spark of consciousness is another ripple of that original transition, another echo of the universe choosing to unfold. The moment creation chose to happen is not just behind us. It is happening still, right now, in every heartbeat of reality. And within that moment, reality began its long journey to become aware of itself. We return, finally, to the question that opened this odyssey, the question that has been our compass through every layer of existence. What created reality before reality? We began by treating it as a puzzle with a missing piece, a mystery waiting for an answer. But now, after traveling through timeless realms, quantum oceans, inflating multiverses, and the fragile emergence of time itself, we begin to see that the question may not point to a single truth. It may point to something deeper. Perhaps the question is not a doorway to an answer. Perhaps the question is the answer. We asked what came before, only to discover that before is a concept tied to time, and time is not fundamental. We asked what triggered the universe, only to learn that trigger and sequence may be human constructs, shaped by a mind that evolved inside linear time. We asked why the universe chose to exist, only to find that existence itself may be a natural expression of probability and instability, not a decision, but a transition. And so the mystery remains, not because it hides from us, but because we may be framing it in a language reality itself does not speak. The closer we come, the more the question dissolves, like a reflection rippling away in water. But in that dissolution lies something beautiful: humility. The recognition that our universe began in mystery, unfolded in mystery, and may return to mystery again. That the unknown is not an obstacle, but an invitation. That some truths are not meant to be solved, they are meant to be witnessed. The universe began with mystery, and perhaps it will end with one too. A soft breath into the void,